Good afternoon, I'm Jeremy Echols, and I'm going to talk to you about the basics of refrigeration and how an air conditioner works. This is a ubiquitous technology that is important for everyone's life. We all contact it every day of our lives. It increases our quality of life by allowing us to live in hot and humid climates, and it keeps our food from spoiling. So it's interesting to understand a few simple concepts about how the refrigeration and air conditioning systems work. There's two key concepts that I'm going to point out, and the first is the physics behind the process, and we'll go over that, and the second is the basic equipment that's common to all refrigeration systems. So I'm going to use the digitized version of a dry erase board here. So let's talk about the physics behind the process. Now this represents a compressed gas cylinder, and it's filled with these tiny red dots that represent a compressed gas, and these tiny red dots represent individual molecules. So when molecules are packed tightly together, they bump up against each other and create friction, and the result is that they have a lot of kinetic energy. If you're to open up this valve at the top here and allow these molecules to escape, as they expand, they lose that kinetic energy, and the result is that lowering of the temperature. Now this is common to all gases, and that is the fact that a compressed gas will actually exist as a liquid. The molecules are so close together that they're actually in a liquid, and they don't turn to a gas until you let the pressure off of them and they're allowed to expand. Now we can use any gas to do this same process with, but for refrigeration purposes we have some criteria that we use, and the first is non-toxic, that the gas be non-toxic. The second is that it's non-corrosive. The third is that it's non-flammable. And fourth, that it has a low boiling point. So that's basically all of the physics behind this process. Now let's talk about the basics of the equipment itself used in the process. I've outlined 6 different key elements that represent the loop that makes up a refrigeration system, and all this is a big giant loop. It's very simple, and it has 6 different parts. The first part is the refrigerant gas itself, and I've depicted that again with these tiny red dots that travel around this loop. The second element is the oil. That's actually, the purpose of the oil is to lubricate the moving parts within the system, and the oil just travels with the red dots, or with the gas, and it's hard to represent the oil in this picture. The third element of this system is the compressor itself, which is the heart of any refrigeration system. The compressor compresses the gas by moving a shaft back and forth, and it builds up pressure on this line here. And as we come down in the diagram, we find the expansion valve. And the expansion valve's purpose is to just form a restriction between the expansion valve and the compressor itself to allow it to build up pressure. And the expansion valve has a small orifice in the end of the expansion valve and allows this gas to escape slowly. And as the gas escapes, it travels down to the evaporator coil. And I've outlined the evaporator coil here with a box to represent whatever you want to be cold, because this is the point in the system where the cold air is actually produced. So we leave the evaporator coil, the refrigerant gas leaves the evaporator coil and travels up to the next type of coil, which is called a condenser coil. And this is actually the last element of the system. And the condenser coil purpose is to condition this gas and bring the temperature back up and send it on its way to becoming a liquid again, so that the compressor can receive it and continue the cycle. And that's basically how simple the refrigeration process is. In closing, I would just want to reiterate a few of the key points that I've talked about here. And the first is that we can use the expansion of a compressed gas to result in a cooling process that we can harness to make refrigeration work. And the second point I want to reiterate is just the 6 key elements that are used in the process. The refrigerant gas, the oil, the compressor, the expansion valve, the evaporator coil, and the condenser, and they all work in a loop. So the next time you open your freezer up, be thankful for physics and the engineers that apply physics to keep our green beans cold. Thanks very much.